Yes, we have full screen of your voice, so the floor is yours.
Thank you.
Thank
Perfect.
you very much.
Yes, my name is Jonas Wibom. I am head of business development at Ragn-Sells. And Ragn-Sells is a waste management company. How do I change to next picture? That's way. We've been around for quite some time. It's still a family-owned company. And our vision is to be a living proof that care for the earth and good business go hand in hand. So that's quite an inspiring vision to work from. Some quick company facts. We have a turnover of some 600 million euros, 6 billion Swedish kronas. We are active in Sweden, Norway, Denmark, and Estonia, and we handle some 6 million tons of materials each year. We do lots of stuff. We are operating landfills, we are collecting waste, we are recycling paper and plastics and all that sort of stuff, and working with hazardous materials in general, really. So we come from the ash, waste ash side of this. We invented this technology that I'm about to present because we needed a new technology. We've been working with ashes for quite a while, but using sort of the same solidification stabilization that Mr. Stakanora mentioned a few minutes ago. But we think we need a new technology for the circular society. We are working with a few basic principles when we are developing our technologies. We need technologies that really reduce the need for use of virgin resources. And we also want them to decontaminate the circular flows. We have lots of stuff in circulation that we need to take out of circulation. So the waste or incineration business is really the kidney of the system. That's one place where we can take out unwanted stuff. And we also want our solution not to push any debts to future generations. As you know, if you're here, one of the problems with the fly ash is, one of the problems with fly ash from waste incineration is the high content of salts. On the left here, you see the staples are the limits for landfilling of hazardous waste in Sweden and the European Union. And the yellow staples are actually the salt contents in some of the ashes. So this is, of course, a big problem, but also a possibility if you like to recycle stuff. The challenge that we had to come over is we have a big site in west of Stockholm, Högbytorp. It has a good location for ash treatment since it's in the middle of quite a few incineration plants. But we have a freshwater recipient, so we can't discharge any salty water or any other contaminated water, of course, into this water body. So we chose to focus on the chlorine salts rather than the heavy metals. We needed to create an off-site solution to meet these needs of our customers. Most of the plants are maybe too small to have an on-site solution, or they don't have enough space to have one. And we also needed a technology. Since we are not ash producers, we needed a technology that can handle a different feed of ashes over time, since we are subject to public tendering. I mean, the contracts come and they go away and the ash mix is changed. Also, our customers changed their fuel mix, and maybe changes in the flue gas treatment technologies due to regulations and other demands will change the quality of the ashes. So we needed a very robust technology. And as I said, they must produce very clean water. And as a worst case, the residues should meet criteria for being able to be landfilled on a non-hazardous waste landfill. And also, any eventual products produced should meet our guiding principles. So we looked around for a while all across the world, didn't find any solution that met our challenge or our needs, so we had to create our own. So our tech sibling, Easy Mining, came up with the ash to salt technology. It's not going to look like this. It's going to look like the picture that you maybe see behind me, or I'm going to show it later. But this is just to, it's easier to explain. The ashes are coming in to these silos, number one. And this is the same as before. They come in on truck today, hopefully electric truck in the near future. And then the ashes go into this washing plant, number 3. And this is, as I said, it's known technology. And we can wash it with different kind of water. I lost my cursor, but number 2 in the bottom of the screen, you can see we have processed water, we have landfill leachate and everything. And we can wash the ashes and produce a salty brine, which then goes on to building number 5, which is the actual invention, ash to salt. And in here we produce clean salts, and we also produce a very clean water that can go back to the washing plant. It can go to other processes in these on the site, or it can be released to recipient. Simplified process. The first step is the actual ash washing, the washing of the ash. We wash with water. It's a high pH process. And we produce, in this step, it's a well-known technology, and we have also teamed up with a very experienced partner in this. I'll come back to that. And we produce the ash residue, the washed ash, so to say, and then we take out some of the contaminants to make the next step possible. Next step, we come to the first of the ash to salt operations, and that's evaporation of this pre-treated brine. That was a hard sentence. I need to take some water. This is the evaporation step, and in this step we create ammonium sulfate, and we also separate calcium chloride. And how do we do that? Yeah, we do that by using the fact that in the mixture, the calcium chloride and the sodium chloride and the potassium chloride, which are the 3 main salts in this brine, they have different solubility in each other at different conditions. So we can use that in a very ingenious process that is patented by Easy Mining. And so we can separate the calcium chloride, and on to the next step, we have a mix of potassium chloride and sodium chloride. So once again, we use a solid liquid separation cycle, also taking advantage of the fact that these salts have different solubilities under different conditions. And that's really the process. And then lots more to it, of course. But this step number 2, this is the only evaporation operation we have, and thus it's very energy efficient. Yeah, what do we produce? We produce, of course, lots of ash wash residue, which is could be landfill as a non-hazardous waste under EU regulations, or it could be used, hopefully, as a process chemical in some industry. The salts that we produce potassium chloride, could be used as a fertilizer, of course, or maybe some industrial chemical. The calcium chloride is mainly used for roads, the dust control and de-icing. Then we have the sodium chloride, of course, always also used for roads, but we are aiming to industrial processes, a bit more noble use of this very pure sodium chloride that we produce. And then we have the aqueous ammonia or ammonium sulfate, and that's a good story. We can recirculate some of this back as air pollution control agent to the plants that has produced the ashes. We also established a partnership with a very experienced and competent partner in the salt market to help us market the salts from this plant we're building. Michael gave me a few specific questions to focus on. I'll try, I think I already answered most of them, but I'll repeat for clarification. The first step, washing, that's quite simple and well known. And we have teamed up with the partner Hitachi Zosen Innova, which has massive experience from washing of ashes, and also the name behind the Fluva technology that will be presented later. So the technical challenge was the salt splits, as we didn't find any that met our needs. And this was the main challenge to invent the energy efficient technology. I don't think energy will be cheaper in the future, and use of waste heat will come at the price. There will be no waste in the future, hopefully. It's only one evaporation step. So we use the saturation and crystallization cycle instead. So that's energy efficient. We didn't want the technology that need lots of chemicals, hardly any actually. Washing with water was the solution to that, reduces the chemical handling. And we also needed it to be insensitive to the proportion in salt feed. And the technology actually takes care of that itself. It's very robust and it separates the salts due to the ash to salt patent. And we needed to produce clean salts of commercial quality, so we needed to take away any unwanted substances from the salts. Since we don't want to produce any mixed salt brine for maybe road use, we wanted to be pure salts that really replaces virgin material. And also we didn't want it to consume high quality water, so we had to build in a water cleaning system, not only to not contaminate the salts, of course, but also not to have to use pristine water. We teamed up with HZI to accomplish, they actually realized the technology, and it has worked out really well so far, and in the future, we trust. Other technical challenges, of course, when you're working with these materials, we have the high pH level. We have formation of H2, as some ashes produces quite a lot of hydrogen gas when mixed with water. We don't want to blow the factory up. We have to remove the unwanted substances from the salt. We have to do that before we go into the salt cycle and also during the salt extraction. And then, of course, we're working with high concentration of brine, and it's always a challenge to work with evaporation in that. Going forward, we will, of course, have the problem of implementing this technology at full scale, but it's a well-known operations applied in a novel way with an experienced partner. So we think we can accomplish that. And also the washing reduces the hazardous of the ash residue, but it's not fit for reuse yet. Next step will be to refine this residue in order to recycle it. Washing with water gives us some advantages with positive properties and also some disadvantages with negative properties. But we're working on that. Hopefully we'll realize that as well. Another question from Michael was the possibilities and the barriers. The possibilities is that, we have a full-scale plant under construction at the moment, which will prove this concept, hopefully. And it's an off-site solution, as I said, no modifications needed at the incineration plant, which we think will make it easier to implement this technology. It's a robust technology. We can handle any mix of ashes. And also, there are lots of ash washing plants around, and the ash to salt technology can be applied to any of those. Has a negative climate impact, means good climate impact, since we are, the climate impact from producing the salts somewhere is vanishing. Also some barriers, we need a reasonable scale. It has to be fairly big, maybe 50,000 tons of ashes. So for a remote location, maybe too expensive, and also on site at the incineration plant, it will be a bit too expensive. I'm running out of time, so I will be fairly quick. We don't think we need any policy measures. This was another question. The future is already here, and we are building. Some general promotion of circular economy. We need a level playing field to virgin resources. That's about that. The layout. This is the construction site. 2 weeks ago, we have started groundworks. So it's actually happening for real. And the project timeline is that we did the demolition before summer. We are now doing groundworks. We will start building the actual building and equipment lift in later this winter. It will be completed for start of the testing in a bit more than 1 year from now. And then we'll do the tests and performance tests, and then we will take over in August 22. So this is a timeline. Okay, I think that's about it.
Thank you very much, Jonas. So several questions came in, and we just have about 5 minutes to go through them. You have answered some of them already, but you answered that per today you cannot really recycle the residue with the heavy metals. That's a challenge you have to work on in the future, right?
Absolutely, we're working on that, and we have some ideas, and our aim is absolutely to be able to recycle it. Yes.
Yeah, to have complete solution. A question about the calcium chloride. Is there really a market for that? How easy is it to store it also?
Yeah, we believe there is a market. Otherwise, we would have gone from one problem to maybe a larger problem. So now the analysis is we have a market, and as I said, we have a partner within the salt in the salt market, been there for quite a while, and they are confident there will be a market for the calcium chloride, at least for road use. Yes.
Good. Again, somebody is very interested in the dioxins. Do you have to do anything specific in your process, or do you do anything specific in the process about that?
Yeah, we have considered dioxins, of course. Yes, we believe, or we are quite certain that they will end up in a certain place, and we'll take care of it. We are actually in a race with other technologies at the moment, and we think we're on the leaderboard. So I can't be too specific, but yes.
No, I understand. But yeah, it's on your radar, of course. Yeah. So good. And then there was a question, 2 questions around maybe the full-scale plant and the economy, the scale of everything. I don't remember. Did you mention what do you expect to be a good scale for such an off-site plant, so a centralized plant?
Yeah, the one we're building now out of Stockholm is for 130,000 tons a year. And that's the sort of size we ended up with, considering the market size in the vicinities and the economy of scale. Maybe we could go a bit smaller in the future, but as I said, I think maybe 50 or 80,000 tons would be the smallest size as we see it at the moment.
So it's not only for domestic market, maybe? No, you don't have to reveal any strategy either, but yeah.
No, we think this, this first plant is really for the domestic market in Sweden. We're quite large on waste incineration, produce some almost 300,000 tons a year of fly ash.
Yeah.
But we are looking to other countries as well, of course.
Thank you. And then we can finish with, of course, a question about money. So in this model, who will pay? How do you make money?
We make money in the same way as we always make money. The polluter pays. This will,
yes.
the ash producer is our main customers, the value of the salts are not even close to the total cost of operations. So it will be the incineration plants that pay, but we believe that the old style land filling solutions will not be acceptable in the future.
Yeah, exactly. I think that was the question. It was to see how much of the money could come from the products versus the...
Yeah, I mean, amount maybe say between 10 and 25% of the revenue could be from the produced product.
Okay. Thank you very much. Maybe one last question very fast. It was a question about the footprint of the plant. It's not very clear. I guess footprint is mainly the...
the size of the building.
Area.
The size of, you can relate to the truck and the people, of course, but the size of this building is some 50 meters by 45 meters by 30 meters. So this is quite a large one, but it's the first also.
Yeah, it's like maybe this many incinerators type size. Not
it's like a small incineration plant in size. Yes.
Thank you very much. I think